Hello everyone, welcome back. In today's lesson, we are going to learn about Azure management and governance tools. In the previous part, we learned about identity and access management, Microsoft Entra ID, authentication, authorization, RBAC, hybrid identity. Now we will move into another important area of Azure, management and governance. Once an organization starts using Azure, managing hundreds or thousands of resources becomes a major challenge. Companies need tools to deploy resources efficiently, monitor application health, control costs, enforce security standards, automate repetitive tasks, protect critical resources. Azure provides a complete set of management and governance tools to help organizations operate securely and efficiently. What you will learn in this module? By the end of this lesson, you will understand the core Azure management tools required for the AZ900 exam and real world cloud operations. We will cover Azure Portal, the graphical interface for managing Azure resources. You can use the Azure Portal to create Azure resources, configure services, monitor applications, manage subscriptions. For example, an administrator wants to create a virtual mission. He can just simply select the virtual missions and he can create and he can configure settings and he can deploy using Azure Portal. For this, no need any code knowledge. So he can simply click on the virtual mission and he can create it. Azure Cloud Shell, a browser-based command line environment. It supports Azure CLI, Azure PowerShell. The benefits of this is no local installation required, access from anywhere, pre-authenticated Azure environment. For example, an administrator uses Azure Cloud Shell to create resources using commands. Instead of clicking through the portal, he will use commands. Next one, Azure CLI and Azure PowerShell. Azure CLI is a command line tool that works across platforms like Windows, Linux, Mac OS. He can just simply create a resource group. For example, he want to create a resource group. He will just use AZ group create. It's like a user-friendly commands. Azure PowerShell, a scripting environment designed for automation. For example, we need to deploy hundreds of virtual machines. Then we can use this Azure PowerShell automation. Infrastructure as a code. Infrastructure as a code allows organizations to deploy Azure resources using templates and code. Azure Resource Manager templates and Bicep, Terraform, these all are the infrastructure as a code for repeatable deployments and consistent environments and faster provisioning. We will use this infrastructure as a code. Azure Resource Manager, ARM, is the deployment and management framework behind Azure resources. ARM templates allow organizations to define infrastructure using code for repeatable deployments, consistent environments, and faster provisioning. Azure Monitor and Azure Advisor. Azure Monitor provides metrics, logs, alerts, performance insights. For example, a virtual machine CPU usage reached 90%. Azure Monitor detects the issue and sends an alert. Azure Advisor. Azure Advisor provides personalized recommendations. It helps improve cost, security, performance, reliability. For example, Azure Advisor recommends resize this underutilized virtual machine to reduce monthly cost. Resource locks and tags. Resource locks prevent accidental changes. Here we have two types of resource locks. Delete lock, it prevents deletion. Read only lock, it prevents modification. Tags are metadata labels attached to Azure resources. They help organize resources. For example, a company has hundreds of virtual machines. Using these tags, we can identify which missions are from finance team, which are from HR team, which are from development team. Like that, we can segregate the resources using tags, and also cost reports can be generated by department. Managing Azure resources. How do I manage Azure resources? Microsoft provides a multiple ways to interact with Azure depending on your experience level and the task you need to perform. The three most common management tools are Azure Portal, Cloud Shell, Azure CLI. Although all three can manage Azure resources, each is designed for different scenarios. For example, we can explore one by one. Azure Portal. It's a graphical way to manage Azure. The Azure Portal is Microsoft's web-based graphical user interface, often called a GUI. You simply sign in through a web browser and can manage almost every Azure resource using menus, buttons, and guided wizards. With the Azure Portal, you can create virtual machine, you can deploy storage accounts, you can configure virtual networks, you can manage databases, you can monitor applications, you can view billing and subscription. Everything is done visually, making it easy for beginners. So, in what scenario we will use this Azure Portal? This Azure Portal is ideal for learning Azure. Whoever are newly learning Azure, they can use this Azure Portal, because initially they will not be having any code skills. That time they can use this Azure Portal, and for one-time deployments and viewing the dashboards and monitoring resources, troubleshooting, managing small environments, we can use this Azure Portal. Azure Cloud Shell. Azure management from any browser. Cloud Shell is a browser-based command line environment built directly into the Azure portal. One of the biggest advantages is that you don't need to install anything on your computer. It already includes Azure CLI, Azure PowerShell. This means you can start managing Azure immediately after signing in. Imagine you are traveling and your laptop has just been replaced. You don't have Azure CLI or PowerShell installed. Instead of spending time installing software, you just open Azure portal and you just simply launch Cloud Shell, and you can start managing Azure resources immediately. So everything is ready to use. Benefits of Cloud Shell: no software installation is required. It accessible from any browser. It supports both Azure CLI and PowerShell. Uses your Azure account automatically after you sign in. It's a great choice when you are working on a shared computer or a newly configured device. Azure CLI: fast cross-platform command line management. Azure CLI is Microsoft's cross-platform command line tool. It runs on Windows, Linux, Mac OS, unlike the graphical Azure portal. Azure CLI uses commands to manage Azure resources. It's especially useful for automation and repetitive tasks. Suppose your company needs to create 20 storage accounts for different branch offices. Using the Azure portal, you would repeat the same steps 20 times. With Azure CLI, you can write one script that creates all 20 storage accounts automatically. This saves time and reduces errors and ensures consistency. Why DevOps teams prefer Azure CLI? Automation is essential in modern cloud environments. Azure CLI allows engineers to automate deployments, manage resources in bulk, integrate with CI/CD pipelines, build repeatable scripts. Instead of manual clicks, the same script can be executed whenever it needs. Here, Azure portal, it is beginners and one-time task. And Azure Cloud Shell is a browser-based management without installation. Azure CLI is for automation and for scripting. Azure PowerShell. If you have worked as a Windows Server administrator, chances are you are already familiar with Windows PowerShell. Microsoft extended this same PowerShell experience to Azure, allowing administrators to manage cloud resources using PowerShell commands. For Windows administrators, Azure PowerShell feels natural because it uses the same scripting language and command structure they are already comfortable with. It's one of the most popular tools for automating Azure administration, especially in enterprise and hybrid environment. What is Azure PowerShell? Azure PowerShell is a collection of PowerShell modules and commandlets that allow you to create, configure, monitor, and manage Azure resources. Instead of clicking through the Azure portal, you write PowerShell commands that perform the same tasks automatically. This makes administration faster, more consistent, and easier to repeat. PowerShell is especially useful when you are managing hundreds of users, multiple virtual machines, large Azure environments, hybrid infrastructures. Rather than performing repetitive tasks manually, you can automate them using scripts. Windows PowerShell is a natural fit for organizations that already manage Windows Server and Active Directory. If your IT team uses PowerShell for creating Active Directory users, managing Windows servers, configuring group policies, automating administrative tasks, then learning Azure PowerShell is straightforward. The same scripting skills can be used to manage Azure resources. Imagine you are using PowerShell to create users in an on-premises Active Directory environment. Now, your organization adopts Microsoft Azure and Microsoft 365. Instead of learning an entirely new management tool, you can continue using PowerShell to manage Azure virtual machines, storage account, virtual networks, Microsoft Entra ID users, Microsoft 365 resources. This makes the transition to the cloud much easier for Windows administrators. One of the biggest advantages of Azure PowerShell is automation. Imagine performing the same task hundreds of times manually. That would be slow and repetitive, right? And that can be human error. PowerShell solves this by allowing you to write a script once and run it whenever it needed. For example, a company hires 50 new employees. Each employee need Microsoft Entra ID account, Microsoft 365 license, membership in the correct security groups. If an administrator performs these tasks manually through the Azure portal, it could take several hours and it can be a manual errors. Instead, the administrator runs a single Azure PowerShell script. The script automatically creates all 50 user accounts and it assigns a 365 license and it attach security groups. So this all will happen in few minutes. And also there will be a chance of reducing mistakes. Many organizations operate in hybrid environments where some resources remain on premises while others are hosted in Azure. Azure PowerShell allows administrators to manage both environments from a single console. For example, you can manage on-premises Active Directory, configure Azure virtual machines, create Azure storage accounts, manage Microsoft Entra ID users, all using PowerShell. This unified approach simplifies administration and improves productivity. Consider a healthcare organization that still has on-premises Active Directory but also uses Microsoft Azure for cloud services. Using Azure PowerShell, an administrator can create a new employee in Active Directory, synchronize the identity to Microsoft Entra ID, assign a Microsoft 365 license, add the employee to security groups. All these steps can be automated in one PowerShell script. Azure PowerShell offers several advantages. It automates repetitive administrative tasks and reduces manual errors, saves significant time, supports large scale deployments, integrates well with Windows Server environments, ideal for hybrid cloud environment. When should you use Azure PowerShell instead of Azure CLI? The answer depends on your environment. Choose Azure PowerShell if you are a Windows administrator. You already use PowerShell extensively and you manage hybrid Windows environment. You need advanced scripting capabilities. You can choose Azure PowerShell. Azure CLI if you work across Windows, Linux, Mac OS and you are part of DevOps or automation team. You prefer lightweight cross-platform command line tools, you can use Azure CLI. Both tools can manage Azure resources effectively. The choice depends on your workflow and experience. Infrastructure as a code. So far we have learned about Azure Portal, Azure Cloud Shell, Azure CLI, Azure PowerShell. These tools are excellent for creating and managing resources. But imagine this situation. Your company needs to deploy the same Azure environment in development, testing, production. Would you manually create every virtual machine, storage account, virtual network, and database 3 separate times? Not only would that take hours, but it also increases the chance of mistakes. This is exactly why infrastructure as code or IAC was introduced. What is infrastructure as a code? Infrastructure as a code is the practice of defining your cloud infrastructure using code instead of manually creating resources. Think of it like following a recipe. Instead of remembering every ingredient and every step each time you cook, you write the recipe once and follow it whenever you need the same meal. Infrastructure as a code works the same way. You define your Azure environment once, save it as code, and Azure can deploy the same environment, repeat code. Let's look at the 3 technologies that make it possible in Azure. Azure Resource Manager, also called ARM templates, Bicep. These are closely related and it's very common to see questions about them in AZ 900 exam. Let's understand each one with real world examples. Azure Resource Manager. ARM is the management and deployment service for Azure. Think of ARM as the traffic controller for Azure resources. No matter how you create a resource, the request always goes through ARM before Azure provisions it, whether you are using Azure Portal, Azure CLI, Azure PowerShell, REST API or Terraform, ARM templates or Bicep. Every deployment request is processed by Azure Resource Manager. This centralized management ensures that deployments are consistent, secure, and compliant with organizational policies. Imagine your company has 3 different teams. Cloud administrator creates resources through the Azure portal. DevOps Engineer deploys infrastructure using Azure CLI. Automation team uses Terraform. Although they use different tools, every deployment is sent to Azure Resource Manager. ARM validates the request, checks Azure policy and RBAC permissions, and then creates the resources. This guarantees a consistent deployment process regardless of the tool used. Why ARM is important? Azure Resource Manager provides several important capabilities: consistent deployment across all management tools, centralized authorization using Azure RBAC, integration with Azure policy for governance, dependency management between resources, resource organization using resource groups. In simple terms, ARM is the engine that powers Azure deployments. ARM templates. An ARM template is a JSON file that describes your Azure infrastructure. Instead of manually creating resources one by one, you define everything in a template. The template can include virtual machines, virtual networks, storage accounts, databases, security settings, dependencies. Because it's a declarative, you describe the desired end state and Azure figures out how to create it. Suppose a company needs to deploy 50 identical web servers for a global application. Creating each server manually would be time consuming and could lead to configuration differences. Instead, the cloud engineer writes one ARM template. The template defines the VM size, operating system, virtual network, network security group, storage configuration. Azure Resource Manager reads the template and automatically deploys all 50 servers with the same configuration. This eliminates manual errors and ensures consistency. Bicep. Bicep is Microsoft's modern language for writing infrastructure as code. It performs the same job as ARM templates but with a much simpler and cleaner syntax. Think of it this way: writing an ARM template in JSON is like writing a long detailed essay. Writing the same deployment in Bicep is like creating clear organized bullet points. The information is the same, but Bicep is much easier to read, write and maintain. Bicep does not replace ARM. Instead, Bicep is another way to create ARM deployments. When you deploy Bicep file, Azure automatically compiles it into an ARM template behind the scenes. That means ARM templates and Bicep produce the same Azure resources. The difference is only in how you write the deployment definition. Imagine a cloud architect need to deploy a complete application environment. That environment includes 2 virtual machines, 1 storage account, 1 virtual network, 1 Azure SQL database. Instead of writing hundreds of lines of JSON, the architect writes a concise Bicep file. Azure compiles the Bicep file into an ARM template and deploys the environment automatically. The result is exactly the same, but the code is much easier to understand and maintain. ARM template versus Bicep. ARM template like file format in JSON and Bicep is a simple language. Readability, ARM template more verbose and Bicep is cleaner and simpler. ARM template is more complex but Bicep is easier. Deployment engine, Azure Resource Manager, even in Bicep also Azure Resource Manager. ARM template also creates Azure resources. In the same way, Azure resources will be created in Bicep. Imagine a multinational company opening new regional offices. Each office requires the same Azure infrastructure. The cloud team writes a single Bicep file describing the environment. Azure Resource Manager deploys identical infrastructure for every office. This approach ensures consistent deployment, faster provisioning, easier maintenance, fewer configuration errors. Monitoring Azure. After deploying Azure resources, the next important responsibility is monitoring the health, performance and security of your environment. In a traditional data center, administrators could walk into a server room, check hardware and troubleshoot physical systems. But in the cloud, resources are distributed across virtual machines, applications, databases, storage accounts, networks, multiple regions. So organizations need powerful monitoring tools to maintain visibility. This leads to an important cloud principle. You cannot manage what you cannot see. Visibility is the foundation of a healthy Azure environment. Why is Azure monitoring is important? Without monitoring, organizations may not know when an application becomes slow, when a server runs out of resources, when a security issue occurs, when a service becomes unavailable, when costs increase unexpectedly. Azure monitoring helps teams identify problems before they impact users. Azure monitoring provides three key capabilities: metrics, logs, insights, and alerts. Now let's explore the core Azure monitoring services. Azure Monitor, Log Analytics Workspace, Application Insights, Azure Workbooks. Together, these tools provide complete visibility into your Azure environment. They help organizations answer important questions. Is my application healthy? Are my servers performing well? Who changed a resource? Why did an error occur? Are users experiencing problems? So let's explore each service. Azure Monitor. Azure Monitor is Microsoft's centralized monitoring platform that collects data from your entire Azure environment. It collects metrics, logs, events, alerts, performance data from resources such as virtual machines, applications, databases, storage accounts, networks. How Azure Monitor works? Azure resources generate data. Azure Monitor collects and analyzes the data. Administrators receive insights and alerts. Teams take action before users are impacted. Imagine a company hosts an online application on Azure Virtual Machine. Normally, CPU usage stays around 20%. Suddenly, due to increased customer traffic, CPU usage increases to 95%. Azure Monitor detects this unusual activity. It can automatically generate an alert, notify administrators, and trigger automation actions. The operations team can investigate and scale resources before customers experience slow performance. Log Analytics Workspace. Central location for log data. A log analytics workspace is a centralized location where Azure stores and analyzes log data. It allows administrators to search through large amounts of operational data uses like Custo query language. KQL is a query language designed for analyzing Azure logs. What can you find using logs? Who accessed a resource? When did a failure occur? What caused an error? Which user performed an action? So we can find using these logs. For example, an employee reports, I could not access the application yesterday at 2 p.m. Instead of guessing, the administrator opens log analytics. They search authentication logs using KQL. Within seconds, they discover the exact login attempt, the user account, failure reason, timestamp. This makes troubleshooting much easier and much faster. Application Insights is an application performance monitoring service, also called APM. It is designed especially for monitoring applications. It tracks response time, application availability, exceptions, user requests, dependencies. Imagine customers complain the checkout page takes 15 seconds to load. The development team needs to find the reason. Application Insights analyzes the application flow. It discovers the application is waiting too long for a SQL database query. The developers optimize the database query. The checkout response time improves from 15 seconds to 2 seconds. Customers now have a faster experience. Azure Workbooks. Azure Workbooks provide interactive dashboards that combine information from multiple Azure monitoring sources. They can display metrics, logs, charts, alerts, security information all in one place. A cloud operations team manages hundreds of Azure resources. Instead of opening multiple monitoring screens, they create one Azure workbook. The dashboard displays virtual machine CPU usage, storage capacity, application health, security alerts, database performance. This creates a single pane of glass for monitoring the entire environment. Let's compare Azure monitoring tools. Tool like Azure Monitor is using for overall monitoring platform, and it tracks CPU, metrics and alerts. Log Analytics Workspace to store and analyze logs, investigate login failures. Application insights, application performance monitoring. It find slow application components. Azure workbooks, custom dashboards, single view of environment health. Let's imagine an online banking application running on Azure. A company uses Azure Monitor to monitor servers, networks, databases. Log Analytics Workspace to investigate security events, authentication failures, system errors. Application Insights to monitor customer experience, application performance. Azure Workbooks to provide executive dashboards, operations visibility. Together, these services create a complete monitoring solution. In AZ900 exam, remember these key points. Azure Monitor collects and analyzes metrics, logs, and alerts across Azure. Log Analytics Workspace stores logs and allows analysis using KQL. Application Insights monitors application performance and user experience. Azure Workbooks creates interactive dashboards combining monitoring data. In common AZ900 question, which Azure service helps developers identify slow application performance and exceptions? Here the answer is Application Insights. Which service allows querying Azure logs using Custo query language? The answer is Log Analytics Workspace. Azure monitoring follows Azure resources. Azure Monitor collects data. Log Analytics analyzes logs. Application Insights monitors applications. Azure Workbooks visualize everything. These tools help organizations detect problems early, improve performance, and deliver reliable cloud services. Azure Advisor. Azure Advisor is like having a cloud consultant reviewing your Azure environment 24/7. It continuously analyzes your Azure resources and provides personalized recommendations to help you improve cost efficiency, security, reliability, performance, operational excellence. What is Azure Advisor? Azure Advisor is a free recommendation service built into Azure. It analyzes your environment and identifies opportunities to improve your cloud deployment. It reviews resource configurations, usage patterns, security settings, performance data, cost trends. Then it provides actionable recommendations. How Azure Advisor works? Azure resources. Then Azure Advisor analyzes your environment and its recommendations are generated, and then administrators review and apply improvements. Imagine a company has been running several Azure virtual machines for 6 months. Azure Advisor analyzes usage pattern and discovers some VMs are rarely used. Certain resources are oversized. Some configurations could be improved. Azure Advisors Like advisor recommends resize these virtual machine to a smaller size and reduce monthly cost. The company applies the recommendation and saves money without affecting performance. Azure Advisor recommendation categories are like cost optimization. Azure Advisor helps reduce unnecessary spending. It identifies underutilized virtual machines, unused resources, possible reservation opportunities. For example, a development team creates a large virtual machine for testing but only uses it a few hours per week. Azure Advisor recommends resize or shut down this VM when not in use. This helps reduce Azure costs. Security. Azure Advisor helps improve the security posture of your environment. It provides recommendations related to identity protection, network security, access control, security configuration. For example, Azure Advisor detects a virtual machine does not have recommended security settings enabled. It recommends security improvements. Reliability. Reliability recommendations help ensure your application remain available. Azure Advisor checks for high availability improvements, backup recommendations, resource configuration issues. For example, a production application is running on a single virtual machine. Azure Advisor recommends deploy additional instances for better availability. Operational excellence. Operational excellence focuses on improving how you manage Azure resources. The recommendations may include better monitoring, resource management improvements, configuration best practices. Azure Advisor recommends enabling monitoring for critical resources. This helps administrators detect problems earlier. Performance. Performance recommendations help improve application speed and efficiency. Azure Advisor analyzes resource utilization, network performance, application workloads. A database is experiencing high demand. Azure Advisor recommends upgrading the database tier into improve performance. Azure Advisor versus Azure Monitor. Azure Monitor focuses on what happening right now. CPU usage, errors, logs, alerts. But Azure Advisor focuses on how can we improve, reducing cost, improve security, increase reliability, like this. Now let's look at real world examples of how Azure Advisor helps organizations improve their Azure environments. Cost optimization, reducing Azure spending. Like imagine a company is running several virtual machines for an application. Azure Advisor analyzes the usage patterns and discovers 3 virtual machines are running with only 5% CPU utilization. This means the VMs are much larger than the workload requires. Azure Advisor recommendation. Azure suggests resize these virtual machines from standard D4 to standard B2. The smaller VM size provides enough computing power for the workload while reducing unnecessary spending. Business impact, like earlier you have large VM size, low utilization, higher monthly cost. After this Azure Advisor recommendation, right sized VM and same application performance, lower Azure bill. The company saves money without affecting users. Security improvement, protecting storage data. Now let's look at security. Imagine a company has an Azure storage account containing important business data. Azure Advisor detects the storage account allows public access. This means data could potentially be exposed if security controls are not properly configured. Azure Advisor recommends like disable public access, enable Microsoft Defender for storage, improve storage security settings. Here the business impact with one configuration change, like before storage account exposed to unnecessary risk. After this Azure advisory, like Azure advisor recommendation, like public access disabled, advanced threat protection enabled, better security posture. A potential security gap is closed immediately. Performance optimization, improving database speed. Now let's look at performance. Imagine an application uses Azure SQL database. Users complain the application is responding slowly. The development team investigates and discovers that some database queries are taking too long. Azure Advisor recommends, like, it analyzes database performance and recommends enable automatic indexing. Automatic indexing allows Azure SQL database to identify inefficient queries, create recommended indexes, remove unnecessary indexes, optimize query performance. So here, before slow database queries, longer application response time. So after advisory, like Azure advisory, like optimized query paths and faster database operations and improved user experience, the application becomes noticeably faster within hours. Reliability improvement. Imagine a production application running on a virtual machine. The VM is deployed in only one availability zone. This creates a risk. If that zone experiences a failure, the application may become unavailable. Azure Advisor recommends deploy an additional virtual machine in another availability zone. This creates redundancy. So here, before Azure Advisor, single VM. After that, single point of failure, like possible downtime. After VM in zone 1 and zone 2, higher availability. Like earlier, it is a single point of failure because VM is only in single zone. But after that Azure Advisor, VM in zone 1 and zone 2. So high availability. Application continues running even if one data center experiences a failure. Enterprise scenario, like let's imagine a company running a customer facing application in Azure. Azure Advisor reviews the environment and provides recommendations. Resize unused virtual machines, remove public storage access, optimize database queries, add availability zone redundancy. The organization improves its cloud environment without manually reviewing query resources. So here the Azure Advisor benefits are reduce unnecessary cost, improve security posture, increase application reliability, optimize performance, follow Azure best practices. Azure Service Health and Azure Resource Health. Although their names sound similar, they answer different questions. Let's understand the difference. Azure Service Health. Monitoring the Azure platform. First, let's look at Azure Service Health. Azure Service Health provides information about the overall health of Azure services. It tells you about events that may affect your applications, including Azure service incidents, regional outages, planned maintenance, health advisors. Service health focuses on is Microsoft Azure having an issue that affects my services. What does Azure Service Health provide? Azure Service Health includes three major areas: Azure Status, Service Health, Planned Maintenance. Azure Status provides information about global Azure service issues. It answers, is Azure experiencing a widespread outage? Service Health. Service Health provides personalized alerts based on your subscriptions, your Azure regions, your deployed resources. It shows issues that specifically affect your environment. Planned maintenance. Azure regularly performs maintenance to improve reliability and security. Service Health notifies customers about upcoming maintenance and expecting impact recommended actions. Imagine a company runs a customer-facing application in East US Azure region. Microsoft schedules planned maintenance that may affect some infrastructure. Azure Service Health sends a notification several days in advance. The IT team can review the impact, schedule a maintenance window, and inform business stakeholders and prepare contingency plans. Instead of being surprised, the organization can proactively respond. Resource Health. Monitoring individual Azure resources. While Service Health monitors the Azure platform, Resource Health monitors individual resources. Example of resources: virtual machines, databases, storage accounts, app services. Resource Health answers, what is the health status of my specific Azure resource? Each Azure resource reports one of four health states: available, unavailable, degraded, unknown. Available. The resource is healthy and operating normally. Example, a virtual machine is running successfully with no issues. Then resource health is healthy and operating, it shows available. The resource is not functioning correctly, it shows unavailable. A virtual machine cannot start because of an Azure infrastructure infrastructure problem, then it shows unavailable. Degraded. The resource is running but performance may be affected. A database is available but experiencing reduced performance, then it will show degraded. Unknown. Azure cannot determine the current health state. Example, monitoring data is temporarily unavailable, then it shows unknown. Imagine an application server suddenly stops responding, the operation team checks the application code first. Then they open Azure Resource Health. They see unexpected host failure. This immediately provides important information. The issue is not caused by the application. The problem is related to Azure infrastructure hosting the virtual machine. The team can focus on recovery actions instead of spending hours troubleshooting the wrong area. Azure Service Health versus Resource Health. Let's see the difference. Azure Service Health focuses on Azure platform issues. Azure Resource Health focuses on individual resources. Azure Service Health scope is Azure services and regions. Azure Resource Health scope is specific resource. Azure Service Health, for example, regional failure. For Azure Resource Health, VM failure. Azure Service Health inform customers about Azure incidents. Azure Resource Health diagnose resource health. Imagine a company runs application across multiple Azure regions. A problem occurs, the operations team checks Azure Service Health. Is Microsoft reporting a regional outage? Then they check resource health. Which specific resources are affected? Together, these services help team quickly identify what happened, where it happened, who is impacted, what action to take. So here you have to remember Azure Service Health provides information about Azure incidents, planned maintenance, regional outages, health advisors. Resource Health shows individual Azure resources. It states available, unavailable, degraded, unknown. So here, for example, AZ9 in AZ900 exam, like they asked which service provides information about planned Azure maintenance events. Is it Azure Service Health or Resource Health? Azure Service Health. Which service helps determine whether a specific virtual machine is affected by an Azure infrastructure issue? The answer is Resource Health. Resource logs. As organizations grow their Azure environments, they may manage hundreds of virtual machines, multiple databases, thousands of storage accounts, resources across multiple subscriptions. With so many resources, two important challenges appear. How do we prevent accidental changes to critical resources? How do we organize and identify resources efficiently? Azure provides two simple but powerful governance features to solve these challenges. Resource logs, Azure tags. Resource logs protecting important Azure resources. Resource logs prevent accidental modification or deletion of Azure resources. Even users with high-level permissions may be blocked from performing certain actions when a lock is applied. Resource locks are especially useful for protecting production databases, critical virtual machines, important storage accounts, networking components. Why use resource locks? In large organizations, accidental changes can happen. For example, an administrator may accidentally delete a production database while cleaning up unused resources. A resource lock adds an extra layer of protection. Azure tags organizing Azure resources. Tags are metadata labels attached to Azure resources. They help organizations organize, identify, and manage resources. A tag is simply a name equal to value. In large organizations may have thousands of Azure resources. Without tags, it becomes difficult to answer questions like who owns this resource, which department uses it, is it production or development, how should costs be allocated. Tags provide this information instantly. Protecting and organizing resources. Delete lock. It prevents accidental resource deletion. A delete lock prevents users from deleting an Azure resource. This protection applies even to administrators who have permission to manage the resource. A resource can still be viewed, configured, modified, but deletion is blocked. Imagine a company runs a customer-facing application using an Azure SQL database. An administrator is cleaning up unused resources and accidentally selects delete database. Normally the database would be removed, but the database has a delete lock. Azure blocks the deletion request. The administrator receives a message that resource cannot be deleted because a lock existed. The production database remains safe. Delete logs are commonly used for production databases, critical virtual machines, network resources, business critical applications. They protect against human mistakes, accidental clicks, incorrect automation scripts. Read-only lock. It preventing configuration changes. This is the second type of lock. Read-only lock allows users to view a resource but prevents changes. Users can open the resource, view the settings, monitor performance, but they cannot modify configurations, update settings, delete the resource. Imagine a financial organization has a production application that must meet strict compliance requirements. The security team wants administrator to monitor the environment but prevent unauthorized changes. They apply a read-only lock. Now, auditors can view configurations, administrators can monitor resources, unauthorized modifications are blocked. This helps prevent configuration drift. So here the difference between delete and read-only lock is delete lock allows viewing and it allows changes and it will not allow to delete. But read-only lock, it allows viewing but it will not allow to change or delete. Delete lock prevents against deletion. Read only lock protects against all modifications. Azure tags. Tags help organizations organize and classify Azure resources. A tag is a simple key equal to value pair. For example, environment equal to production, department equal to finance, owner equal to platform team, or application equal to payroll. Like that we can apply tags. Why are Azure tags important? In large organizations may have thousands of resources. Without tags, it becomes difficult to understand who owns a resource, which department uses it, what application does it support, how much does it cost. Tags provide this information automatically. Imagine a company has Azure resources used by different departments: finance, HR, sales, engineering team. Each resource is tagged like department equal to finance, department equal to HR. Like that it defined the resources. Azure cost management can use these tags to group expenses. Finance team can generate reports such as how much did the finance team spend on Azure this month. No manual tracking is required. A cloud administrator discovers a virtual machine named VM Production 23 tag name. So they need to know who owns it, which application uses it. Is it production or testing? Tag provide the answer, right? It is a environment is production, owner is a platform team, and application customer portal. Like that it will provide, the tags will provide the information about that resources. Throughout this module, we learn about different Azure management and governance tools: Azure Portal, Azure CLI, Azure PowerShell, ARM templates, Bicep, Azure Monitor, Azure Advisor, Resource Logs, Azure Tags. Azure tags. Now let's understand how all these tools work together in a real enterprise environment. Azure operations are not separate activities. They follow a continuous life cycle. Plan, deploy, manage, monitor, optimize, improve. This is how modern cloud teams operate Azure environments. Every Azure environment starts with a deployment requirement. For example, a development team needs a new application environment. They need virtual machine, storage account, database, virtual network, security configuration. The team can deploy resources using different tools: Azure Portal or Azure CLI, Azure PowerShell, ARM templates, Bicep, Terraform. Azure Resource Manager, regardless of which tool we are using, every request goes through Azure Resource Manager. ARM is the central management layer of Azure. ARM as the control center that manages all Azure deployments. After resources are deployed, governance controls are applied. Organizations use Azure RBAC, like who can access resources, what actions users can perform. Then it protect using resource logs, production databases or critical applications, and important infrastructure. Those we can protect using resource logs. Then Azure tags to organize ownership, department, environment, cost tracking. A production database is deployed. The cloud team applies RBAC. Database administrators get required permissions. Resource log, delete log prevents accidental removal, and tags applied. Tags like environment equal to production, owner, database team, application, customer, portal, like that. Monitoring with now after deployment, continuous monitoring begins. Azure Monitor collects metrics, logs, events, performance data. It watches resource health and application behavior. A company runs an online shopping application. Azure Monitor detects CPU usage, like it increases from 30 to 95%. The system generates an alerts. The operations team investigates before customers experiencing performance issues. And then troubleshooting, we can troubleshoot with logs. When an issue occurs, team use log analytics workspace to analyze detailed information, and Kusto query language using KQL, administrator can search authentication failures, resource changes, application errors, security events. And then optimization with Azure Advisor, Azure Monitoring and Environment. Azure Advisor provides recommendation. It analyzes cost, security, performance, reliability. A virtual machine is consistently underutilized. Recommendation: resize the VM and reduce cost. The operations team reviews and applies the recommendation. The complete Azure operation like workflow is Before we complete this module, let's review the most important exam concepts. AZ 900 is not only about memorizing Azure service names. Microsoft frequently tests whether you understand which tool should be used for a specific real-world scenario. The key is understanding the purpose and use case of each service. Let's review the most important points. Portal versus CLI versus PowerShell. Azure Portal is a graphical user interface or GUI. It will be used. You prefer a visual interface. You need to perform one-time tasks. You are learning Azure. Then you can use Azure Portal. Azure CLI. It's a cross-platform command line tool. It works on Windows, Linux, Mac OS. It uses for automation, scripts, DevOps workflows. Azure PowerShell. Azure PowerShell is a commandlet to manage Azure resources. It is ideal for Windows administrators, enterprise automation, hybrid environments. ARM and Bicep. Azure Resource Manager is the deployment and management backbone of Azure. Every Azure deployment request passes through ARM, whether you use Portal, CLI, PowerShell, Terraform, ARM templates, or Bicep. ARM manages the deployment process. Bicep is a modern infrastructure as code language from Microsoft. It provides cleaner syntax, easier maintenance, better readability. But Bicep does not replace ARM. Bicep compiles into ARM templates. Monitor and advisor versus service health. Azure Monitor, like what is happening in my environment right now. It provides metrics, logs, alerts, performance monitoring. Azure Advisor, how can I improve my Azure environment? It provides recommendations for cost optimization, security, reliability, performance. Azure Service Health, is my Microsoft Azure itself experiencing an issue? It provides Azure outages, planned maintenance, service advisors. Resource logs, it protect important Azure resources from accidental changes. Here we have two types of logs are there. Delete log, it prevents deleting resources, and then read only log. We can only view the resources. Thank you for joining. I hope this lesson helped you understand the key concepts of Azure management and governance tools. Azure Portal, CLI and PowerShell, ARM and Bicep, Azure Monitor, Azure Advisor, Service Health, Resource Logs and Tags. These concepts are important not only for the AZ900 Azure Fundamentals exam, but also for understanding how real-world Azure environments are deployed, managed, secured, and optimized. If this lesson was helpful, please support the channel and help others discover this content.